Hello folks. Today we're going to be getting into one of the last few sections for the year, and that will be a skill that will help you solve quadratic equations in geometry. And so many times in geometry you've got this equation that has a square in it basically. So we haven't done this at all. You've got to know how to factor. And so this section right here starts out with calling it using the distributive property. Now, there's a lot in this section. You already know the distributive property, but it's more working in reverse, okay? So you may recall that if you have A times B plus C, you could distribute that through the parentheses and be left with AB plus AC. And so this is taking the distributive property forward. What we're going to be doing in this section and in the remainder of the sections is taking something like this and writing it as a product. Okay, because that will become very valuable to do in math to solve equations. Okay. So we're going kind of in reverse. So for example, if I give you something like this, right, the instructions are going to say factor. And when you factor something, you write it as a product. So when you factor something, the first thing you're going to ask yourself is if you can take out a greatest common factor from every term. So we have a binomial here. And if you were to do this kind of very slowly, you would look first at the 15x and you would write it as its prime factorization. So 3 times 5 times x. 25x squared. Sorry, dog is barking. 25x squared is 5 times 5 times x times x. Now what they have in common, what their greatest common factor is they each have a 5 and they each have an x. Right? They might have a 5 and a 2, a 5 and a 3, right? So they could have more than one factor and also more than one variable in common. So what you do is you then say, well, that's the greatest common factor, which I know you've done in the past, GCF we call it, right? That's 5x. And you want to factor that out, we say. So now you are tasked, you're supposed to write this as 5x times something. And whatever you get, right, you should end up with what they originally gave you. So that's the whole idea of factoring. So you can do this a couple different ways, all right? Sometimes students say, well, I just figure out what I need to multiply by to get what they gave me. So 5 times 3 is 15, and I just need an x, so I don't really need another x there. So it should just be a 3. And then the other term, right, you would say 5 times what is 25? 5. X times x would be x squared. Okay, so this would be the factored form. This is the answer we're looking for now. All right, so notice how they gave me a binomial. I take out a monomial, and if they gave me a binomial, I should have a binomial in the parentheses. There you go, you can see it. All right, so this is me checking over here on the right side. The answer is the product. Okay, so let me show you another one of those. Okay, sometimes we start out with a trinomial. So if we were to start with 12xy plus 24xy squared minus 30x squared y squared, I need to think of what is the monomial that is a factor of all three of these, okay? So I'm looking at 12, 24, and 30. So once again, you know, you can make a list of these if you wanted to, right? Or you could make a tree. All right, some people do it like that. So 2 times 2 times 3 times an x and a y. Right, and so you would do this for each one of them. 2 times 2 times 2 times 3 and x, y, y. And then for the 30, well, that would be 2 times 3 times 5. Once again, you can make the tree times x, x, y, y. Right? So this is a process that some people go through to do this. And so now they're going to say, well, what do they have in common? So I see that they all have a 2. Okay, these guys have a 2, but I don't have another 2 here. So that wouldn't be a factor of all 3. The 3, right? They all have a 2 and a 3, and I think that's it. So the GCF so far would be 2 times 3, which is 6. And then what do they have in common? Well, for this one, it's just easiest to say, well, what's the smallest number of x's they have in common? So they each have at least one x, and they each have at least one y. So xy would be what they have in common. Right, so that's 6xy. Okay. Now, I'm not saying that you have to go through that process of making a list like that, all right? Some people need to do that. Some people like doing that to be sure. You do want to be sure that you take out the greatest common factor. So now that I know that 6xy is the GCF, all right, let me show you another way that sometimes people do this, okay? Once they know that the GCF is, right, in this case, 6xy, they write that on the outside. And then to figure out what they have inside, what they do is they divide that into each of the monomials, right? So that's why we spent some time doing that back a couple sections ago, right? If you were to divide that, you would be able to figure out what you'd have to multiply by to get this, right? So if you do that for each term, plus 4y, negative divided by positive is a negative, and so that would be 30 divided by 6 is 5xy. Okay. So as you do this, when you factor something out, you shouldn't have any common factors inside. So I kind of check myself by looking at those 2, 4, 5, they don't share any common factors, and I don't have, you know, an x in everything or a y in everything. So I've taken out what I needed to take out, okay? And again, I started out with a trinomial, so I should end up with a trinomial. Okay. So this is taking out a greatest common factor from all terms in the given polynomial. Now that doesn't always happen. You can't always take something out. There are some instances that when you have 4 terms, you can do something called grouping. Okay. When I look at these 4 terms, there isn't a number that goes into all of them, and there isn't a variable that they all share, okay? However, if you were to group them, all right, and always try to group them first 2, last 2, like this. So when I group them, I'm going to make sure this is attached by addition. So if I had a minus here, I would do plus negative, but it's a positive, so. Right? Group the first 2 and the last 2, and now take the greatest common factor out of just each pair. So for these 2, I see they both share an x, right? So if I divide each term by x, I'd get 2y plus 7. And now when I take something out of this grouping, I want to make sure I have the same thing left over. Okay, and I'll show you why. If I were to take out a 1, which is the only thing I can really take out here, I would be left with this same binomial, right? You could always factor out a 1 because 1 is a factor of everything. Now at this point, when I look at this, right, this is a factor of this, and it's a factor of the second part. So you can actually take this binomial out as a common factor. Right, so if I pull that out in front, I'm going to get 2y plus 7 times x plus 1. Right, sorry for the... There you go. Can you see that, guys? All right. Factoring by grouping is a little bit weird. I think that when I do this in class, sometimes I'll go ahead and I'll say, well, what if this were a big old, an A? Right? Think of what you would do. If that were an A, you would say, right, if you had x times A plus 1 times A, you could factor out an A. So you could pull that in front. So you'd have A times x plus 1. Well, here the A is just the 2x plus 7. So it's a little bit different. All right, let's try another one of those before we go on, because I think it is important to look at a few of those. Okay, my next example 4. So once again, with the 4-term problems, you can't really take something out of all 4 terms, not in this case and in many of these cases. So when you have something like this where you can't take something out of all 4 terms, sometimes you can still factor it if you group. Okay, so once again, I'm going to group the first 2 and the last 2. I'm just going to try that first, see how that works. That's usually a good way to start. And now I'm not looking at the whole thing. I'm just looking at each pair. So for this pair right here, right, I've got a 2 and a 12. So 2 is a factor of both, right? So I can take out a 2. And I can see that they both share an m. So I can factor out an m. So when I factor out the 2m, I'm left with k minus 2 times 12 would be 2 times 6 would be 12. So I'm left with a k minus 6. Right? And remember, you could always check by distributing it back and see if you get what you started with. Now, when I take something out of this, I really want to end up with the same thing in parentheses, so then that can be factored out. Okay? So I almost set myself up for that by just copying this here. And then I figure out, okay, what would I have to take out in order to get that in the parentheses? So when I look at that, I say, oh, I'd have to take out a 7 because that would leave me with the k minus 6, so plus 7. So remember, this is a factor of this, and this is a factor of this. So now you can take out this as a common factor. Right, so you're taking out the k minus 6, and you've got 2m plus 7. And now remember, you can always check these, because if you were to FOIL this out, like we learned in the last few sections, you would end up with this original problem. All right, and that's always the way you can check to make sure. Okay. Now, you might be wondering, okay, why are we going through all the trouble of factoring when you just had me spend an awful long time on multiplying everything out, Mrs. Smith? So why did we do that for 3 weeks? So the ability to go back and forth is really important because that foiling checks the factorization or the factored form of the polynomial. And if we're going to know how to solve quadratic equations, so what does that word quadratic mean? An equation in the form ax squared plus bx plus c equals 0. So notice, right, we used to solve equations like this without a squared. Now we're throwing in that ax squared term. If we're going to be successful at solving equations like this, we need to know how to factor. Okay? Because if you can write something in factored form, right? So let's say you're given something like this, right, with numbers obviously, and you get down to a factored form of it. All right, so let's say you have this, where you have the product of these two binomials is equal to 0. At that point, you're going to have the ability to solve that equation, okay? If you multiply two things and you get 0, what must you know about one of those things? Well, it can't be like a 5 times a 3, right? That's not going to be 0. It can't be a negative 2 times a negative 7, right? That's not going to be 0. One of those things you're multiplying has to be equal to 0. And this is called a very important property. It's called the zero product property. And it says that if a times b equals 0, then one of two things have to be true. Either a has to equal 0 or b has to equal 0. And the a and the b can be bigger than just an a or a b. It could be, 5x plus 2, 3y minus 7. So here, the a is like the x minus 2. So we can say, well here, either x minus 2 has to equal 0, or the b, which is this part here, 4x minus 1 equals 0. So now we have two very simple equations that we really know how to solve very well, right? These are linear equations. And so if you take that equation now and you get x alone, right, you'd add 2. Sorry, the red doesn't show up. I don't know why I keep picking up the red. So we'd have x equals 2, or, right, here you'd add 1, divide by 4, so we get x equals 1/4. Right? So we get two answers, 2 and 1/4, and we could put those in the solution set notation. We get the two answers. Okay? So the problem is that you're not going to be given problems like this where it's already factored, either with parentheses or maybe a monomial times a binomial. You're going to have to figure that out. Okay? So this is where we're heading. And this is kind of like the destination, why we're teaching you how to solve these quadratics. Okay, would say solve, and then we've got an equation. And just by looking at the equation, we know that this is not just a run-of-the-mill get the variable by itself. And the reason for that is that you've got that y squared in there. Okay. Now sometimes students ask me, well, Mrs. Smith, why can't you just divide both sides by y? Then you wouldn't have a y squared anymore. Well, when you divide by y, you are opening up the possibility that you may have just divided by 0. Okay? You never want to eliminate one of your possible solutions, and you never want to divide by 0. You know that that's not defined in math. So this is what you do. Okay? There are some very careful steps that you want to go through. And I have these written in my notes on Schoology. First thing is to get one side equal to 0. Okay, so here we've got variables on both sides, so just decide where you want it. I like to have a positive in front of the x squared or the y squared, so I'm going to bring the 14y to the right side. So I've got 0 on the left now equals 12y squared minus 14y. Those are not like terms, so we can't combine them because one is y squared and one is a y. Okay, I'm back. Sorry about that, folks. We're at the home stretch. So, as I was saying, the whole goal of learning to factor is to be able to solve quadratic equations. And so, once you have one side equals 0, if you can factor this into two things, right, like we just said, that zero product property allows you to solve. So we're going to always start by taking out the GCF, right? So the second step would be to factor. All right, can you take out GCF? It's usually what we're going to be doing in the beginning to get used to the concept. So you're thinking 12 and 14. What number is a factor of both? You can do the factorization, the prime factorization, or if you know your math facts, you know that 2 is the largest number that divides evenly. So we've got 2 and a y, of course. And so now we should have a binomial, right? We're factoring a binomial. We take out a monomial. So what's left? 7y minus, oops, no, I'm sorry, not 7y. 2 times 6 is 12. And 2 times 14, 2 times 7 is 14. Whew, answering the door really threw me off there, I'm sorry. And so now we've got this in factored form. So again, remember, you can check this by distributing, if it's just a monomial times a binomial, or a monomial times a trinomial, or you can FOIL it out if you have 2 binomials. So when you distribute this, yep, I'm just doing it in my head. 2 times 6 is 12. Y times y is y squared. Good. 2y times minus 7 is minus 14. Yes, I got it right. All right, so that was me checking. Once I know and I'm confident that I have it factored, now I set each factor equal to 0. Okay, so if this product equals 0, then either 2y equals 0 or 6y minus 7 equals 0. Okay, and then you're going to solve each one of those equations. Sorry about that. Okay. So when you have 2y equals 0, you're going to divide both sides by 2. And you're going to get y equals 0. And then here you'd have to add 7 first. And divide both sides by 6 to get y equals 7/6. Okay, so you're going to get 2 answers for most of these when you do a quadratic equation. Not 100% of the time, but the majority of times. Okay, please try the homework sheet. I'm using a skill sheet this time. And please do the review on Delta Math. Okay, folks? Thanks so much, and I hope you have a great day. Enjoy the sunshine if you can, and I hope everybody's doing well. Take care.